Hello. In the previous video, we discussed how to find the zeros of the polynomial function graphically by using ICT. Now, uh, I will like to discuss uh, algebraic way to calculate the zeros or the solution of the polynomial equation. So, I would like to start with the first degree equation. First degree equation, we can call it linear equation. So how can we find the roots of the linear equation? So this is the linear equation, first one, simple linear equation. Writing here this linear equation. So how can we write the linear equation? So this is linear equation. 2x minus 4 is equal to 0. I'm starting with the very simple one. What is linear equation? How can we recognize an equation as linear equation or linear polynomial? We have discussed in the previous section, in the start of this chapter, probably in the first lecture, uh, that if the degree of the polynomial is 1, then this is called linear polynomial or first degree polynomial. So if we substitute this one equals 0, then this is linear equation. So how can we find its solution or 0? So first, what will we do? We will take negative 4 on the other side. This will become 0 plus 4. So this is 2x is equal to plus 4. And 4, we will divide on both sides by 2. 4 divided by 2, and this 2 is cancelled with this 2. So it means that this x is equal to 2. So this is one example for the solution of linear equation. So now I'm going to give you another example. Uh, Example 2, like this is minus 3x plus 5 is equal to negative 7 plus 11x. So what we have to do here, we have to collect the x terms on one side. So how can we do this? This is negative 3x and this is plus 11x. We will take it on the left side of this equal sign. Actually, we are trying to write the similar terms on one side of equal sign. So this is negative 7 and then plus 5 will come on the right side. This is negative 5. So negative 14x is actually equal to negative 12. So negative 14x we will divide on both sides by negative 14. So why we are dividing on both sides with negative 14? Actually, we are uh, making this x alone. So this negative 14 is cancelled with this negative 14. So x is equal to negative sign is cancelled. So it will make it positive. And 12 over 14, this is equal to 6 times 12 and 2, 7 times 14. This is 6 by 7. You can also write this answer into the decimal also. So this is the way to calculate the zeros for the linear function or equation of the first degree. So now I'm going to move at second degree equation. So this is second degree equation like 2x square and this is negative 3x and this is negative 5 is equal to 0. This is second degree equation and we also call it quadratic equation. Second degree equation. So what is the best way to calculate the zeros are the roots of the second degree equation, quadratic equation. We can also call it quadratic equation. So best and easy rule to calculate its roots is the quadratic formula. So what is the quadratic formula? Uh, I'm writing it here. Ax square, suppose this is equation, second degree equation, ax square plus bx plus c is equal to 0. So this is the quadratic formula. X is equal to negative b plus minus square root of b square minus 4ac divided by 2a. So this is second degree equation. Uh, uh, and this is second degree equation, and this is its quadratic formula to calculate its roots. This factor b square minus 4ac, which is inside the square root, this is called the discriminant. This is also called the discriminant method to find the zeros, or we also call this whole formula as quadratic formula. So how can we do this? Coefficient of x square, which is a, coefficient of x, this is b, and constant term without x, this one, this is c, this is equal to -5. So we will write here quadratic formula x is equal to negative b plus minus square root of this b square minus 4ac, this is a, and then divided by 2a. So we will substitute these values a, b, and c in this formula. We will plug in these values. So this is the negative sign, this one, this negative sign, we will write here this negative sign, and then b. Then what is the value of b? This is the value of b, which is -3 plus minus square root of negative square of -3. It is necessary to use air brackets around -3 minus 4ac, 4, what is a, this is 2, and what is c, this is -5. We will extend this one, and then 2a. X is equal to, this is 3 plus minus square root of 9. This is square of -3 is 9. And then this negative times negative, this is plus 4, 2 times 8, this is 8. And 8, 5 times 40, so divided by 4. So what next? X is equal to 3 plus minus 49 divided by 4. So this is x is equal to 3 plus minus square root of 7 and then divided by 4. So what is x? X is actually equal to 3 plus 7 divided by 4, and this is x is equal to 3 -7 divided by 4. So this is 10 by 4, and this is equal to -4 by -4. So you can also simplify these two if you want, like x is equal to 10 by 4 can be written as 5 by 2. You can also use decimal sign here. And this is x is equal to -4 divided by 4. This is -1. So these are the zeros for polynomial function for this equation, or solution of this equation. Okay, next, uh, I would like to give you another example. for this quadratic equation or solution for the quadratic equation. Like uh, this is equation x square, another example, x square negative x negative 3 equal 0. So how can we solve this? Uh, what is the coefficient of x square? If nothing is the coefficient of x square, then it is 1. A is actually equal to 1, and B is, what is the coefficient of x? This is negative 1 again, and constant term without x, this is C, which is negative 3. So we will write here quadratic formula, uh, negative b plus minus square root of, this is b square minus 4ac divided by 2a. Negative 1. I am now plugging these values in this formula. Instead of b, I will write here this negative 1 plus minus square root of b is negative 1 square of negative 1 minus 4ac divided by 2a. So this x is equal to 1 plus minus square root of 1 plus, this is 13, 12. 4 ones are 4, and 4 times negative 3 is negative 12, and this negative plus 12 divided by 2. So this will turn out 1 plus minus square root of 13 divided by 2. So these are the two values. We can write these values separately. Also 1 plus square root of 13 divided by 2. And you can also write this 1 minus square root of 13 divided by 2. So this is the way to calculate the zeros of the polynomial second degree, or the solution of second degree equation. So hopefully you have understand this. In this video, what I have done so far, I have tried to explain you how to solve the linear equation or quadratic equation. So now what will we do? There is another way to calculate the zeros of the polynomial function. If the polynomial is in the factored form, so for this purpose, we will use this zero product property. Sometimes you may come across the function like that f of x is equal to like x minus 1, x plus 5, and let's just 3x square minus 2. This is 3x square minus 2. So this is the polynomial function, and this is equation x minus 1, x plus 5, 3x square minus 2 equals 0. So this is the zero product property. A product of the factors is 0 if and only if one of the factors is 0. It means that product of all these factors, what are these factors? X minus 1, x minus 1, x plus 5, 3x square minus 2. These are the factors for this polynomial. So this product is 0 when at least one of them is 0. Otherwise, this is not equal to 0. Otherwise, we cannot write here the 0 sign on the right hand side, this one. So this product is 0. This product is 0 if and only if one of them is 0. So Now, we don't know what is this x minus 1 because we don't know the value of x. So we cannot say that x minus 1 is 0 or not. So we will write this equals 0, and then we will write or this can also be equal to 0 because we don't know what is x. So x plus 5 is equal to 0, or this 3x square minus 2 is equal to 0. So we will take this negative 1 on the other side. So this will become 0 plus 1, which is equal to 1. And we will take this plus 5 on the other side. So this will become x is equal to negative 5. And now we will take this 2 on the other side. So this will become 3x square is equal to 2. So now we have to solve this. So 3x square divided by 2 is equal to divided by 3. Sorry, this is 2 divided by 3. We can cancel this 3 with the 3. X square is equal to 2 divided by 3. So we have to this remove square. So how can we remove this square? We can take square root on both sides, plus minus 2 divided by 3 square root. So this square will cancel with the square root, and we are left with x and plus minus 2 by 3 square root. So these are the zeros for this polynomial 1, negative 5, and 2 divided by 3 square root, and negative 2 divided by 3 square root. So this is the solution set for this polynomial. Uh, these values are called zeros of the polynomial, or we also say that these values are solution for this equation. Okay, so this is the way how we use the zero product property. So what next we can do? Uh, I'm going to tell you about another example. This is 2x cubed plus 4x is equal to 0. So how can we solve this one? So we will take common 2x. So this is equal to x square plus 2 is equal to 0. So uh, this was not factored. So first of all, it is needed to factorize this one, because for zero product property, for the use of zero product property, we should have a polynomial function in the factored form. So we have made its factor. This we are taking out this 2x common from both of them. So if we take 2x common from this, we will get here x square, because we have taken one x outside and this 2 outside. Then this 4 is divided by 2. This is actually equal to 2. And we will not write here x because we have taken x outside the bracket. If you multiply this 2x inside, you will get the same thing. So this is the factorization of this one. So now, what is the zero product property? Zero product property says that if product of these two x and x square plus 2 is equal to 0, then at least one of them should be equal to 0. Since we don't know what is the value of x, so we will write this 2x equals 0 and x square plus 2 equal 0. Uh, it is good to write here or sign between them. So now, if you look at this one, now it is the product of 2 and x. So which of them can be 0? Of course, this is 2. This is not equal to 0. So other factor is x. So x is equal to 0. So this is the value of x, or 1, 0 of this equation. So what will we do here? X square is equal to -2. So if you try to solve this equation further, this will give you, uh, it is the common practice, if we have to remove the square root at a square, then we take square root on both sides. So this is square root of -2. You can also write here plus negative minus sign. So x is equal to, if you try to calculate the square root of -2, you will get math error on the calculator, math error. So it means that this equation has no real solution. Okay, has no real solution. This equation has not solution in R. R means set of all real numbers. So because what is the logic behind this? Because there is no any number whose square is equal to -2. Square of any number is always positive. So there is no any number whose square is equal to this -2. So it means that its solution does not exist in R. So uh, actually its solution exists, but not in R. So other solution which exists is complex number, which is outside the scope of this book. So we will discuss only here the real solutions. So I'm not going to discuss this one here. You can leave this also. So this is the only real solution which comes out here, x is equal to 0. So this is all about this video. In this video, I described how to calculate the zeros of the linear function, quadratic equation, and also I discussed few other degree equations also, like this last example is of degree 3. So, and this example is also the degree, this example first green one, this is of degree 4. But I have just told you the simplest way to calculate uh, the roots of these equations. What is the simplest way? And this is the zero product property. And of course, this method has few limitations. What are the limitations to use this method to solve any equation or to find the zeros? The limitation is that we should have the function in the factored form. This function also in the factored form. So if the function is in the factored form, then we can use this zero product property. Otherwise, we cannot use this. So what are the other ways to calculate the zeros or the roots of the equations of the higher degree, like this degree 4 or degree 3? Uh, I will discuss uh, in next few videos this topic. Thank you.